Hi everyone, welcome back to the channel. My name is Priyansh Agarwal, and in this video, let me tell you about my course called TLE Eliminators that I've been running from April 2021. So it's been 3 years since I've been running that course. We have taught more than 5,500 programmers through that course already. Now this entire course, is divided into 4 levels. So for somebody who is at a particular level in their competitive programming journey, they can choose to join a level and learn only those relevant topics. So first of all, you get live classes on all of these topics, right? Every single week, we have around 1 to 2 live theory classes, and we teach you all of these topics in a very structured manner. Secondly, we provide you with curated practice problems on all of these topics that we've taught you. For example, if I teach you dynamic programming for maybe 3 weeks, then in these 3 weeks, I am going to give you 2 to 3 problems every single day. Now, in case you're stuck on any practice problem from the course, you get dedicated video solution where we talk about the exact intuition involved. How do you think? Apart from this, if you're stuck on any practice problem from or outside the course, we provide you with instant doubt support. Now, what happens in doubt support is that we have a team of around 30 to 40 experienced competitive programming mentors. These mentors are already experts and candidate masters on Codeforces, and they help you solve these problems in which you're stuck. Like, you could come up with a debugging problem, you could come up with a problem in which you require some hints, and overall, you get to learn a lot from the experience of these mentors. And apart from that, there are other pretty cool features. You can go and check out our website to explore them. One thing that I want to mention is that TLE Eliminators is a live course, right? So every 3 months, we launch one single batch, and in one single batch, we run all of these level 1, 2, 3, 4 parallelly. So, you can go onto our website and check out when is the next course coming up. And if you're interested, you can sign up for that.
So hi guys, I'm Raghav, and in this video we will solve all the 4 problems of the Leetcode contest. This is the first problem of the contest, Harshad number. It says that if an integer is divisible by the sum of its digits, it is known as Harshad number, and we have been given an integer x. We have to return the sum of digits of x if it is a Harshad number, else we have to return -1. So they are directly saying that in case if a number x is divisible by the sum of its digits, then we have to print the sum of the digits, otherwise we have to print -1. So for this problem, all the prerequisites you have is just you should know how to find out sum of digits of a number. Now this is a standard problem. If you search about it on internet, you will find up some really good resources and solutions as well. So this is something you can learn on your own. Once you're done with it, after that, for solving this problem, all you have to do is, let's say sum is storing the value of the sum of the digits. Then just check if x is divisible by sum, which means that x mod sum equal to 0, whether this condition is true or not. If it is, in that case, we can just return sum. And otherwise, in case if x is not divisible by sum, it means that x is not a Harshad number. So we will just simply return -1. So the problem was quite trivial. All you need to know is just find out how to just find out the sum of digits and do this. This is just implementation based problem. There is no high level logic here. Like, the logic is pretty simple. So that's what I did. Like, this is how I am finding out the sum of digits of a number, and after that I'm just comparing whether the sum is like x is divisible by sum or not. And the time complexity here will be big O of log base 10 of x. So this is just a log of x but with base 10. So if x is something like 100, it will take up only 2 iterations of it. Oh yeah, you don't even need to find out it using while loop, since x will be something smaller than equal to 100. You could have actually done it in a simpler way. The sum of digits of x will either be, like, x can have only 3 digits, right? X can at most have 3 digits, and in the other cases it will have something like 97 or 82, whatever. So the sum is nothing but x mod 10 plus x by 10 mod 10 plus, like, x by 10 will give you 9, and x by 100, that's it. Like, doing mod 10 is not important here since it can be at most 100. So this is also something you would have done here, but I would suggest that you should learn about it, and then the problem is really, really simple. And the time complexity here came out to be log base 10 of x, and the space complexity is constant, so it is big of 1. So we can move on to the second problem, water bottles. In this problem, we have been given two integers, num bottles and num exchange, and this num bottle represents the number of full bottles that you initially have. In one operation, you can perform one of the following operations. Um, Either drink any number of full water bottles, the water bottles which are completely filled. Either drink any number of them, and exchange num exchange empty bottles with one full water bottle. Then increase that num exchange value by 1, and like, you cannot exchange multiple batches of empty bottles for the same value of num exchange. They have been just clarifying this thing, that let's say if you are having num exchange value, sorry, if you are having 3 bottles right now, and the cost of converting empty bottles to filled bottles is 1, then you cannot have 3 empty bottles being converted to 3 full bottles. Instead, you will first of all exchange 1 bottle, then the cost will become 2, then you will exchange 2 empty bottles for the filled bottles, and so on until you are not left up with the required number of bottles to exchange. We have to return the maximum number of water bottles that we can drink. So the problem is just giving us, like, there are 3 things in the problem: the filled number of water bottles you have, the empty number of water bottles you have, and the cost. This cost is nothing but, if you, like, how many empty bottles you need to give, how many empty bottles we need to give to get a full bottle. This is the cost. So these are the 3 things you have. Initially empty 0, filled is equal to um, max bottle, I guess. No, num bottles. This thing is equal to num bottles. This is given to us, and the cost is initially equal to num exchange. And the number of water bottles which we would have drunk, let's call it as answer, which is initially 0. Now what will happen is, like, try to think about it logically, forget about code for now. If you have some filled bottles, and you know that um, you can exchange your empty bottles to get some filled bottles, and you know how many empty bottles you have to give to get the filled bottles, what would you do? I think that everybody would be getting this thing in mind. Yeah, I will drink some of the filled bottles, possibly drink all of them. So I will drink from filled bottles. This will get the count of filled being decreased, like the count of filled bottles will decrease and the count of empty bottles will increase. Then, in case if empty bottle, the number of empty bottles I have is greater than or equal to cost, then I will um, exchange the empty bottles for the filled bottles. So filled bottles count will go up by 1. Empty bottles count will go down by this cost, and the cost will go up by 1. And actually, we will do this thing as long as we can. So instead of saying if, we will say while, as long as you can convert those empty bottles to filled bottles. Right now, we are not really talking about the code. We are just talking about what we will do, what comes as the intuition. If you have some filled bottles and you want to uh, drink the maximum number of filled bottles, you would tend to drink some bottles. It does not really matter whether you drink some bottles, uh, like let's say you have drunk 4 bottles, so you are having 4 empty bottles right now. Now it does not matter whether you exchange these 4 empty bottles first or drink the remaining bottles first. You can do it in any order you want. So we will just do these two operations again and again. One of them is drinking water, and the other one is exchanging those water bottles. Till when we will do this? Like when will we stop? In case if at some point you realize that the number of filled bottles you have is equal to 0, or nay, and like you are not having any more bottles to drink, and empty is less than cost. It means you don't have any more bottles to uh, drink water from, like you don't have any bottles, so you can't drink any more water, and the number of empty bottles you have is not enough. You cannot exchange them for getting a new bottle, a filled bottle. So at that point you will stop, right? This is something which we get as intuition, and that's it. We just have to code this up. There is one more thing. Whenever you drink from the bottle, answer should also increase, because we have to keep track of the number of water bottles we have drunk. So whenever you drink some water bottles, answer will increase by that amount. If you drink X bottles, then answer will increase by X. The number of filled bottles will decrease by X, and the number of empty bottles will also increase by X. This is all really simple thing. And if you exchange some water bottle, like let me now write it a more bit more formally. Let's say if you are drinking X bottles, then your answer will increase by X. Filled number of filled bottles will decrease by X, and number of empty bottles um, will also increase by X. And when you are what to say? Yeah, when you are exchanging some water bottles, empty water bottles with the filled water bottles, then in that case the number of filled water bottles will increase by 1. The number of empty bottles will decrease by the cost. The number of empty bottles you would have exchanged to get some filled bottles, and the cost will also increase by 1. That's it. And we will do this thing till this point, and at last just return answer. So I hope that this thing makes sense. Now let's move on to the code. Um, Here is the code for it. Initially, I said that answer is 0, empty is 0. Then as long as the number of bottles I have, I did not create a new variable with name filled. I just used the same variable which they had given to us. If filled bottles is greater than 0, and the number of empty bottles I have is greater than equal to 0, basically um, at the time when we were stopping, I have just written the exact opposite of that inside the while condition, that if I am either having the number of filled bottles as greater than 0, at least I have at least one filled bottle, or the number of empty water bottles is greater than equal to the number of water bottles I need to exchange for getting filled water bottles, which is the exact opposite of this. And if both of these conditions are true, then I stop. If any one of these is false, so basically, if either this is this holds or this holds, then in that case I will just go on further. There can be two things. The number of empty water bottles can be greater than equal to the cost, or it might be less. In case if it is greater, then what I'm doing is just exchange those water bottles for getting a filled water bottle. And after that, at the time when I'm not having enough uh, empty water bottles, at that time I'm just saying ki whatever filled water bottles you have, just drink all of them, and the number of bottles will become zero. Here in the logic part, we use the word x. We are just taking x as the maximum value that is equal to the number of filled water bottles we have. So eventually we got to this answer. So I hope that this makes sense. We have just implemented the exact same thing which any person would logically do. Like logically, we get this exact same idea. We have just coded it up. So let's move on to the third problem. Count alternating subarrays. In this problem, we have been given a binary array, nums. A binary array is an array which will have each and every value being either 0 or 1. They have also mentioned it here that nums I will either be 0 or 1. And we can call a subarray alternating if no two adjacent elements in the subarray have the same value. And we have to return the number of alternating subarrays in nums. So an alternating array is something like this, where each and every value is different from its neighbor. And since the values can either be 1 or 0, being different means if current guy is 1, then its neighbor should be 0. If the current guy is 0, then its neighbors should be 1, and so on for everyone. And we have to tell the number of alternating subarrays. So like this is an alternating subarray, this is an alternating subarray, this is an alternating subarray. Yeah, if there is a if there is a subarray with just one element, you will call it as alternating. This will also be alternating. And if there are multiple elements, for that you have to check whether they are alternating or not. In this case, all of these are alternating. So what will happen is we will have an array of some binary numbers, sorry, either zeros and ones. Basically, we will have a binary array, maybe something like 10101 only. And we will have to tell the number of alternating subarrays. And by the way, let me give you an example of non-alternating subarray also. Here in this kind of an array, this is an alternating subarray because it is having alternating elements. Similarly for this is an alternating subarray. But this subarray is not alternating because it is having one element being repeated at some place. And these subarrays would also be non-alternating here. Like these would also be not alternating. So we got an idea at the very least. These two elements cannot come together. Like if two adjacent elements are not equal, then they cannot come up together in any subarray. So you know that any subarray starting from any element in this range can go up till only this place. It cannot go till here because that will not be an alternating subarray. I hope that this is looking intuitive. Though we will solve a simpler problem once. First of all, instead of finding out number of alternating subarrays, maybe let's take a simpler case. What if we have an array like this, where the complete array is an alternating subarray? Oh, sorry, where the complete array is an alternating array. Now, what I want you to notice is each and every subarray of this array will definitely be an alternating subarray as well. Whether you take this. So one is an alternating subarray. Every time you get one, all these subarrays which are having only zero are also alternating. 1 0 is also alternating, and like so on. All the subarrays like this one, this one, this one, this one, and basically all the subarrays will be alternating. I hope it makes sense. Just for a small proof for it, logical proof, let us say if like we have been given that this array is alternating, but um, you know that the array is alternating, but in case if it did not really feel intuitive to you that all the subarrays must be alternating, just assume that there is one subarray which is not alternating. So what we mean is, if there is one subarray which is non-alternating, just assume this thing to logically prove whether all the subarrays must be alternating or not. Then what it means is you must have got two consecutive elements of the same value. Like if you want that there is any subarray which is not alternating, it means that it must have uh, equal elements coming up one after the other at some place. And if this thing happens, in that case, the complete array cannot be alternating. If you at any place get two equal elements in a row, then in that case, the complete array cannot be alternating. So I think that now it makes sense कि for why every subarray must be alternating, right? It should now make sense that every subarray must be alternating. Similarly, before that, tell me if there is an array with size 5, how many subarrays does it have? This is something standard. If you have an array of length n, then it will have n into n plus 1 by 2 number of um, subarrays in it. Now I'm not really showing you how it comes up to be this amount, but you can actually try to think about it or search about it on internet if you want. That in an array of length n, you will get n into n plus 1 by 2 number of subarrays. And now let's try to extend this approach we have got for the complete array to a subarray. Let us say if there is an array something like this. As we had got the intuition earlier, any subarray in which this 0 and 0 comes together will not be alternating. Like it can't be alternating actually, right? So you will never have these two together. Similarly, these two these two people cannot be coming up together in any subarray. Similarly for these two, these two, these two, these two, right? Basically, anywhere you see two consecutive elements, you know that two consecutive equal elements, you know that these cannot come up together in any subarray, like any good subarray or any alternating subarray. So what we can do is we can just break down our array into multiple subarrays in this way. Now, let's say if this is an alternating subarray, if it is not having any consecutive elements at any place, it means that this is an alternating subarray, right? As we saw that for an array of length n, there were n into n plus 1 by 2 subarrays inside it. Let us say that this length of this subarray is m. Can I say that this subarray of 6 elements will actually have m into m plus 1 by 2 subarrays inside it, including this complete subarray also? Can I say this thing? If you know how, like for an array of length n, how do we get n into n plus 1 by 2 subarrays? If you know about it, then in that case, I believe that it should be something obvious for you in the exact same way as we were calculating the number of subarrays here. We can calculate the number of subarrays for this subarray as well, and we will get that the formula still works. The formula will work even here, right? For just for clarification, if you want, you could just take up some small value. Let us say we have an array like this one. So after partitions, you will get a subarray of length 4. We will get a subarray of length 4, and the number of subarrays it has inside it is 1, 2, 3, 4, 5, 6, and 7, and then like 8, 9, and 10. Right? It is having 10 subarrays, which is actually gonna work with the formula as well. 4 into 4 plus 1, that is 5 by 2, also comes up to be 10. Right? I was just dry running in front of you to show you that the formula will work. If you know about it, I think that you don't even need the dry run. And similarly, like as we can find out all the possible subarrays inside this subarray, you know that this subarray must start within it and end within it. So there can be no more subarrays containing any of these elements. You can do the exact same thing for all the other alternating subarrays as well. All the maximum alternating subarrays. Just find out the number of the subarrays inside it. So the approach we have got so far is, in the complete array which you have, look up for the places where you find two equal elements at some place, one after the other. Let's say that inside the array, at some point, I found a 0 and I found another 0. I will just put up a barrier in between and say, yeah, all of these elements, this complete subarray we have got so far of, let's say the length is s, then it will have s into s plus 1 by 2 number of alternating subarrays. Just increment that thing into answer. And similarly for this, similarly for this, and that's it. We would have counted each and every subarray in the complete array which is alternating. Now, if you want, you can try to verify this thing on your own also. And let me take up this example. 0, 111. The second example is simply an alternating array is being given to you. So that will obviously give you 10 as the answer. That's why I'm not taking that example here. In this example, you will see that this is one alternating subarray. This is another. This is another. This is an alternating subarray of length 2. So it will actually have 2 into 2 plus 1, that is 3 by 2, which is coming up to be 3 number of alternating subarrays inside it. That is this one, and this one. The other two will have 1 into 2 by 2, that is like 1 into 2 by 2, that is just 1. Similarly, this will also have one subarray. So 3 plus 1 comes up to be 5, and that's our answer. So I think that this is pretty straightforward now. For finding out all of these places where the consecutive elements are equal, it is something you can do in big O of log n, big O of n time. And after that, since you would know about all these lines, actually I did draw a line here and here as well at the start and end of the array as well. Like if you look at it, 0, 1, this line is coming after the index 1. This line is coming after the index 2, this line is coming after the index 3, and this line is coming before the index 0. So if you say that if there had been an imaginary element at index -1, then this line would have been coming up after that. So I called it as -1. I just named them in this way so that If I say 1 minus this minus 1, which will come up to be 2, will give me the number of elements in this range. Similarly, 2 minus 1 gives me the number of elements in this range. 3 minus 2 gives me the number of elements in this range. That is why I have numbered them. And once you know this array, once you get this array, all you have to do is just iterate over it. And while iterating over it, you can just you can just say, let's say that I stored these elements inside some array with name A. Then I can simply say S is equal to A plus 1 minus A. Sorry, A of I plus 1 minus A of I. This will be the number of elements in between. So that's it. We just now have to code it. So here is my code for it. First of all, I I created an array and traversed over it to get all the places where consecutive elements are equal, where two consecutive elements are equal, so that I could draw these boundaries that any element coming up on the left of it can form only subarrays with elements on the left of it. And these are also two boundaries which we created. Otherwise, we would have to write some if-else conditions that in case if this is the first guy and all that stuff. So it is just saving us from some if-else conditions. If you want, just ignore this, and then write up the code if you want. Once we get the array A, I'm traversing over this array A once again. AI plus 1 minus AI will give me the size of the um, subarray which is having all elements alternating, and answer plus equal to sz into sz plus 1 by 2 will give me the number of subarrays inside this range. And remember that we have been accessing a of I plus 1 here, so it's good to just run up the loop till I is less than n minus 1. Otherwise, you will get some error. And similarly here, we are using nums of I plus 1 inside the for loop. So I should be less than n minus 1. When I is equal to n minus 1, in that case, this thing will give you error. So make sure that you run up the for loop properly. And then at the end, we are just giving the answer. And one more thing which you should remember, when at the time when you are multiplying sz with sz plus 1, one thing which can happen is sz, that is the size of the subarray, might be equal to 10 raised to the power 5. When the whole array is alternating, in that case it can actually be equal to 10 raised to the power 5. So 10 raised to the power 5 into 10 raised to the power 5 will actually overflow. So to avoid that, you can multiply the number with a long, basically just typecast the integer sz as long, or maybe just declare it with long. Do one of these things to avoid the overflows. And the time complexity here in this approach is just big O of n. We are having two for loops. The first loop is having a size big O of n, and the second loop is having a big O of n size in the worst case. So overall, the time complexity will be big O of n, and we have been we have created an array A with maximum possible size equal to n. If the whole array is having all the elements equal, in that case, the space complexity will also go up till big O of n. So space is also big O of n, and this is it. By the way, like I'm not gonna discuss another approach, but I would like to give you some hint. There is one more possible approach for this problem, which I think many people might have done. What you could do is, for each and every I, you could just try to figure out how many subarrays will be there which are alternating and end at this place. So if you were having something like 0, 0, 1, 0, 1, in that case, you just need to remember the last time you got some equal elements together, and like if we are considering this point as the ending point, then all of these can be the starting points for all the subarrays starting from any of these points and ending at this place. It can start from anywhere. You will get alternating elements. So what you could do is, for like, just have a for loop going on for whatever name you give to it, I or end, and find out, like, keep track of the last time you had got some element which were both equal. So if this is index 8, let's say that this guy is index 8 7 6 5 4. Yeah. So if you had said here, the last time I got two equal elements, if I had stored that thing as maybe this, the last, like, whatever, in whatever way you store. If you know about this index, if you know about this index and you know about this index, then answer will be just incremented by end minus, let me call this a start for now, end minus start plus 1. Now for now I'm not discussing the complete approach. It will also give the exact same answer. And I do recommend to try out this technique. This is, I believe, a bit more reliable. Maybe this earlier one might be easier to think or easier to code up, but this is a more reliable technique. If there, if the problem had some other variation, in that case, the chances of this technique working is more than the previous one. So, like, by the way, I've not discussed the complete approach. I've just given you some hint. Try to think about it on your own, or you can just search about it in internet. You might find up some solutions with this way of solving in the Leetcode editorial section or the discussion section. Let's move on to the fourth problem. The fourth problem says that we have been given an integer and zero index based array points representing integer coordinates of points on a 2D plane. So points I will be equal to xi comma yi, which is the coordinates of the ith point, and we have to find the distance between 2 points. Oh yeah, they have been saying that the distance between any 2 points is defined as their Manhattan distance. I will tell you what is this Manhattan distance. And what we have to do is return the minimum possible value for maximum distance between any 2 points if we can remove exactly 1 point. First of all, I hope you know that for any point in a 2D plane, it will have some x coordinate and some y coordinate, right? So in the points array we have been given, for every point we have some, like, we have its x coordinate and its y coordinate. These two things have been given to us for each and every point, and the distance between like, uh, let me draw it bigger. If let's say you have 2 points, this one is x1 comma y1 and this is x2 comma y2, then in general we have studied about a way of finding the distance between 2 points as um, x1 minus x2 square plus y1 minus y2 square and square root of that complete, which gives us this value. But in Manhattan distance, I don't remember what we call, like, what is the name of that distance. I think we call it as Euclidean distance, or I don't really remember what we call that. If you ever see the term written as Manhattan distance, they are talking about x1 minus, like, let me make the pen a little this. Then they are talking about absolute difference of x1 minus x2 plus absolute difference of y1 minus y2. This is the Manhattan distance between 2 points. This is a bit different from what we traditionally see. So this Manhattan distance is actually something like this value. the absolute difference upon of x1 and x2 and the absolute difference of y1 and y2. And what we have to do is from the points array we will have where each and every guy will be pointing out, will be having xi comma yi. Oh, yeah, let me use this normal braces here. What we will have to do is consider removing one of the points, and from the remaining points we have been left up with all these points, basically all the points in the array except this middle one, the maximum of um, distance between let's say point j comma point k for all j comma k being greater than equal to 0, less than equal to n minus 1, and j is not equal to I and k is not equal to I. This is a mathematical way of writing it. The thing which we have been given is, like, what we have to do is remove a point from the array, any point of your choice, and once you remove it, you can choose like the answer, like yeah, let's call it as the answer when we remove this point, or the max distance. Let me call this thing as max distance. So if you remove this element, this point, you will have these elements left and these elements left. What is the maximum possible distance between any of these 2 points with each other, which we can mathematically write as distance between any point I and any point j, where j and k can be anything but not equal to I, because I is the point which we have removed. So I think that this mathematical expression should make sense. We should get used to writing such mathematical expressions, because a lot of times it makes stuff easy for us to do. And you know that this dist of, like, distance of point j and k, for now I'm writing pj and pk for representing these 2 points. Distance of pj and pk will be equal to um, x of j minus x of k, absolute of x of j and x of k, plus absolute difference of y of j minus y of k. Right, this is all we have. Now there is one thing you might have noticed. Finding the maximum of some distance which is depending upon two variables j and k, and it is actually an expression of absolute differences, the sum, like the sum of absolute differences of the elements, है ना? Absolute differences, the sum of absolute differences, and we have to take up the maximum of all of that. Like, you can try to think about it. What comes to my mind is there is no simple way of just 1 minute, let me put laptop on charging. Yeah, so what comes up to my mind is there is no simple way of finding out the maximum of all of these elements in any simple way here. You will have to compare on all the j and k, and it will be quite inefficient. But for Manhattan distance, this is one trick which I'm telling you here. There is some code forces block on this for Manhattan distance optimization. I don't really remember the exact name of the code forces block, but I think that if you search this thing on internet, you might find the code forces block, which tells that you can, um, if you have to find out the Manhattan distance between any 2 points, let's say that the variables, the x and y coordinates of those elements are xj, yj, xk and yk, xj, yj and xk, yk. These are the coordinates of the points j and k. Let me say, let me define a new variable x dash j. Let's call it as xj plus yj and y dash j as xj minus yj. If you define, like in similar way, if you define x dash k and x dash j, sorry, y dash k and x dash k, then the distance between these 2 points, distance of pj and pk, will now become equal to the maximum of absolute difference of x dash j minus x dash k, comma um, y dash j minus y dash k. For now, I'm not discussing the proof of it inside right now. I will give the blog link, like I will give the link of the Code Forces blog in description. Um, Somebody had discussed the proof of it there as well. But if you want to just confirm whether it will give you the correct output or not, just consider these 4 cases. Xj will either be greater than k, or xj will be less than xk, or it can be equal, but in the equal case, like just put up equal anywhere you want. And along with it, yj can be greater than yk, or yj can be less than yk, and xj can be greater than xk and yj being less than yk. And in the fourth case, xj being less than xk and yj being greater than yk. These are the only 4 cases. And if you try to find out, if you just try to check key what comes as the distance, the distances in these cases, you will see that this formula is always giving the exact same distance. So if you want, you can check it out, or you can do something like me, who just accepted, yeah, it works. And like at the contest time, I just considered, yeah, it works. And I will try to think of why it works and how to think of this stuff after the contest, basically after the PCT. Now, what is the advantage over the previous one? Previously, the distances of uh, 2 points were actually having a summation between them, and you wanted to find out the maximum of this expression, which is something you cannot optimize in some way. But if you have to find out the maximum of these 2 things, now this is something doable, because you will have to find out the maximum of these and these. Like now the answer for you will be equal to the maximum of the max of xj dash minus xk dash absolute of this for all j comma k, and the maximum of y dash j minus y dash k for all j and k, and take up the maximum of both of these. That will be your answer. Right. Now, um, since since we have to take up the maximum of both of these, and we want to take up the uh, like the distance between 2 points is the maximum of these 2 expressions, and then we will be taking the maximum of all the distances. At the place of distance, if you put up this thing and then try to rearrange a bit, you can get to this expression. This is not a hard thing. If you are writing everything mathematically and trying to write it properly, then making such manipulations is comparatively easy. Now there is one thing in this here j should not be equal to I and k should not be equal to I. By the way, this thing can actually be written in a better way also. If I have to say max of xj dash minus xk dash, I can say it as maximum value of x dash array. Like let's say if I have an array which is having all the values of the x dash I, x dash j and all values, then whatever is the maximum value minus whatever is the minimum value in this. This is like common thing. If you have an array, maybe something like 1, 2, 4, 0, 6, and you want to find out the maximum absolute difference between any two values of the array, then you can just find out the minimum and the maximum values and say our max minus 1 is my answer. For getting the maximum value and minimum value of these elements in an efficient way, what I did is I created a set of integers in which initially I did push everything from x dash 0, x dash 1 till x dash n minus 1. Then since I have to remove the point I just erased x dash I from the set, and then I said here maximum value of x dash minus minimum value of x dash will be the maximum distance. Basically this expression, in the similar way I can find out this as well. So right now let's focus on getting this expression. I just used a set so that I can do this thing efficiently. Once I have pushed up all the elements into the set, removing an element will take big O of log n time of mine, and finding the maximum element and the minimum element, I think that it takes big O of 1 time in the set, since I already know about the iterators uh, where these elements will be present. I believe it should be big O of 1, but at the very least I know that it is less than equal to big O of log n. So even if you consider the case, like even in, we are still safe, right? Even if it is big O of log n, then overall I am able to get the maximum. I am able to get this expression here, maximum of xj dash my max, basically maximum absolute difference between any two points, the x dash of any 2 points. Similarly, I can get the maximum of yj dash minus yk dash for all the y in big O of log n time. After that, I can insert, yeah, you can actually conclude it here. First, I erase x I dash from the set, then I find the maximum distance without it, and then I can insert it back. So in a nutshell, what I'm able to do is for every I, for any I can get the maximum. Uh, for any I can get the maximum distance between any 2 points if I remove that. So if I remove this 5 comma 15, I can get the maximum distance between any two other points other than this one in big of log n. So if I go for every I, if I consider for every I that what will be the maximum absolute maximum Manhattan distance between any 2 points, if I remove this guy, it will come up to be something in big of log n. Like I can find out this thing in big of log n because I will just repeat the exact same process for n elements. So in a nutshell, what we have done so far is we realized first of all a mathematical way of getting the answer. We just got a mathematical expression for our answer. Let me call this thing as result of I If I remove the ith guy, then what will be the result? It came out to be the max of distance between any 2 points pj and pk for all j comma k in the range from 0 to n minus 1. Basically I'm only talking about all the points, and uh, this j should not be equal to I and k should not be equal to I. This is the first mathematical expression I got. I just wrote the things mathematically. Then for the distance of pj comma pk, we can either write the Manhattan distance in the normal way, but since we will be getting the sum of absolute differences and we will have to take up the maximum of all of these, I could not optimize it. At the very least, I don't get any idea of optimizing it, and I don't think that it is at the very least not simple to do. But if we write the Manhattan distance in this way, where x dash j and x dash k will be written in that way, then this is something which is saying here maximum of these two things. So I can just say distance of pj and pk is equal to maximum of absolute difference of x dash j minus x dash k, comma absolute difference of yj dash minus y dash k, where like for j and k we are already having these conditions. So whenever this list of pj comma pk is being called, uh, point j and k already exist. But the idea is here x dash, let me use a variable, um, any variable, maybe I, for whatever point we are talking about. For any point, if we are finding x dash value, then it will come up to be um, xi plus yi. By the way, this I is not the same as this one. Right now we are talking about some other I while calculating it, just for a general expression. And y dash I will be equal to xi minus yi. Now we can just put up this value at this place. So we will get that result I is the maximum of, we will get result I is the maximum of see, maximum value of the maximums is nothing but the maximum. If I say that I have four values 1, 2, 3, 4, and I compare the maximum of these two and the maximum of these two, and I want to pick up the maximum of them, then I can just say that I want to pick up the maximum of the complete array. Similarly, I can here just say that what I want to do is I just want to pick up the maximum value of this for all of the possible j and k, and this for all the possible j and k. So maximum of x dash j minus x dash k for all j comma k, and the maximum of all yj minus y dash k for all 0 to j comma k in the range from there to there, j not being equal to I and k not being equal to I. This is what we have now. You can see this guy, like since all the let's say if you have an array x dash, let's say if you have an array x dash and you want to find the absolute difference of all the elements other than x I in here, like what I did here for this is, for getting this is, I think like there might be some different ways as well, but the way in which I did it is, first of all I assume that I have an array with name x dash where other than the element on the, let's say if there are some elements in this, other than the element on the ith index. For all the other elements, I just want to find out the absolute difference, the maximum absolute difference. So the maximum absolute difference should come up to be the max of all of these values, the max of xj, x dash j actually, sorry, yeah, the maximum of x dash j, like this j right now. This j right now is not actually talking about this. This is a different j. This for only this array. I'm just writing some equation here. Don't get confused with this j and this j. These are two different things. The maximum x dash j minus sorry, yeah, the maximum of x dash j for all j in the range from 0 to n minus 1, and the minimum value of xj for all j in the range from 0 to n minus 1. Like these two are also different. These j's are having their scope only till their own lines, and j is not equal to I here, and here also j is not equal to I here. Basically, if you just find out the maximum possible value in this range, and the minimum possible value in this range, which you can do with prefix sum and prefix max and suffix mix. Like you can just create prefix max and min arrays, both prefix max, prefix min, and suffix max and suffix min array. In that way as well, you can get the maximum absolute difference in just big of 1 for each and every I. It will obviously take big of n time for pre-computation, but every time you will be able to get the maximum minus minimum thing in big of 1. Or the other thing you can do is just push up all the values into this at once. Once you want to get up the maximum and minimum values of these range, basically excluding this guy, then just erase this guy from a set. The other thing which you could have done, other than prefix sum and prefix max arrays, is you could have created a set of integers. Initially push up everything. Then for every I, remove x dash I, get max of x dash minus min of x dash. This is something you can easily get. And then insert x dash I once again. Right, this is something you can do. And you can do this thing for each and every I, whatever, at any place wherever you get the maximum value. Sorry, for each and every I, what you can do is, like for each and every I, with the help of the way we have discussed so far here, you can get the maximum value of this expression and this expression in log and log n time for both of these. Take up the maximum one of them. It will come up to be the maximum absolute difference between any 2 points in the array if you remove the xi index. So, like you would have got result of I in this way, and your answer at the end will be the minimum of this result array, the minimum possible for the result array. This will be our output. Now I know that this thing might have been looking a bit confusing and understanding, but when you try this on your own and try to write up everything mathematically, it should not be that hard. And basically here I had to write up so much mathematical expressions just to make sure that we are like you don't get some wrong idea at any place. But when you're solving it on your own, uh, understanding these mathematical equations would be easier, and at some points you might not even have to write these mathematical equations like this equation. You don't really need to write them when you are solving on your own. So the problem will not really look this complicated, though it's not really that hard if you see. from this point when we started to recap, we got only three equations. This one equation, two equation, the third equation which is coming up from these two, and for this equation, you just have to use a set and do these three operations for x dash and similarly for y dash. So let me show you my code to you. The code is fairly simple. Like thinking about the logic is also not that hard. Just explaining it is actually becoming a bit hard, or maybe understanding when I'm explaining. Basically, somebody else is explaining so much maths might be a bit complicated. But doing this thing on your own is not hard. At first, I declared answer with 1e9 because I have to find out the minimum possible value. So I declared answer with something very huge. I created two multisets. One of them is for x dash and the other one is for y dash. The points, the coordinates of the ith point is x comma y. Then instead of like that I cannot name it as x dash here. So I gave it a name p1, p2. I'm erasing those p1 and p2 from the sets. These are nothing but these x dash sets for x dash. I'm just removing x dash I from them. Like it is equivalent to this part is equivalent to this thing. This part is equivalent to this thing. This part of getting the maximum distance and setting up answer equal to min is equivalent to this part and this part. And then inserting back these points is equivalent to this part. We are inserting back so that when we check for some other I, you will have this point in consideration as well. When you check for this guy, you will have this guy in consideration as well. And at the end, we just return answer. So that's it for the logic part. The time complexity here will be big of n log n, big of n log n time and big of n space and big of n log n time here for this for loop, because we the insert and erase erase functions work in big of n time, and for getting the maximum and maximum and minimum possible values of the basically getting the minimum and maximum values from the set is something you can do it in this way. The minimum value will be present at the beginning iterator and the maximum value will be present at the last iterator, which you can access in this way. Just dereference the reverse iterator. If you know about it, it's very well. If you don't know about it and want to study about it, just search about it. You will get some GFG link, GFG article for it. So I hope that the problem is clear. If the video editorial helped you out, then please consider liking the video and subscribing to the channel. Please give your valuable feedback in the comment section. I will be really happy to see it. And that's it for this video. Thank you for watching and bye bye.